All right, guys, so we just solved one system where we got the correct solution algebraically, and then we found it using matrices with Cramer's rule. So in order to make sure that we feel confident using Cramer's rule, we want to go ahead and try to solve another system, just so we can see how quickly we can get the answer when we decide to use this method. So we have a new system of equations here. This one involves 4x plus 7y equal to 2 as our first equation, and negative 3x minus 2y equals negative 8 as our second equation. So the first thing that we want to do is find the matrix that represents our determinants. That represents our coefficients, not our determinants. So we're going to get the determinant of that matrix. So we want to take our A, B, C, and D values. So remember, those are just the first terms in each of our equations. So A, B, C, D in this case is 4, then 7, then negative 3, then negative 2. So this matrix is generally called A, and then we want to find the determinant of A. So in this case, 4 times negative 2, that gives us negative 8, and we subtract negative 3 times 7. So when we multiply that, we'll get negative 8 minus negative 21. Those values will become positive, and so when we do negative 8 plus positive 21, we end up with 13 as our determinant value. So we're going to hang on to that value for a second while we next find the determinant of this matrix with values E, B, F, and D so that we can solve for our x value. So when we're looking for E, B, F, and D, if we check out our original equation, E is 2, B is 7, F is negative 8, and then our D value is negative 2. So let's go ahead and structure that matrix. So for x, we're going to have E is the 2, B is the 7, negative 8 is the F, and negative 2 is the D value. So here we want to find this determinant, and we do so by multiplying across here first. So that's going to give us negative 4 minus, when I multiply this way, negative 7 times negative 58, that will give me negative 56. So when I do that, I end up adding, so I'll have negative 4 plus positive 56. So when I do that, I will end up with 52. So in order to solve for my x value, I'm just going to take that determinant of 52 and divide it by the determinant of my coefficient matrix, which was 13. So when I divide 52 by 13, I find out that my x value is going to be equal to 4. So very efficient to solve it through this way. Then I also need to find my y value, so I'm just going to set up one more matrix and find its determinant. So the matrix that I set up here comes from this matrix with the values of A, E, C, and F. So looking back at my system of equations, A is 4, E is 2, then my C value is negative 3, so that goes here, and F is negative 8, so that goes here. Then I want to find the determinant of this expression, so I just multiply along here. 4 times negative 8 is negative 32, and then I subtract negative 3 times 2, which is negative 6. So when I do that, negative 32 minus negative 6 is really the same thing as plus positive 6. So this is going to give me negative 26. So to find y, I take that determinant value of negative 26, divide that by 13, and my y value is going to be equal to negative 2. So I think solving systems of equations this way can be a lot simpler, more straightforward than solving with substitution or elimination, because all I have to do is set up 3 matrices and then solve by dividing. So it's a really easy process. I don't have to think through, what do I multiply here to get them to cancel out with elimination? I don't have to worry about accidentally solving for a variable incorrectly with substitution. So it goes by much more quickly for me. Now, this kind of problem solving can also be used for 3 variable systems, and that's something that we will talk about on Monday too, to see how can we take away some of the stress that we sometimes feel when we're trying to solve 3 variable systems if we can just get the solutions by using matrices instead. So we have one more system of equations that we're going to solve using Cramer's rule. And this one's going to be an application problem. So that way we can get more practice translating written expressions into algebraic equations and then solving those with Cramer's rule. So let's take a look at this application problem. Here it says 282 people attended a recent performance of the Nutcracker Ballet because it's Christmas time. Adult tickets sold for $5 and children's tickets sold for $3 each. Find the number of children that attended the ballet, find the number of adults and the number of children that attended the ballet if the total revenue was $1,046. So this problem should feel very similar and familiar to our total cost problems that we solved back when we were starting off with algebraic systems with substitution and elimination. So we have information about the two different kinds of tickets that we're selling. So we can say X is equal to adult tickets. And then the other kind of ticket that we're selling is children's tickets. So adult tickets are X, and I'm going to call children's tickets Y. So then I want to go ahead and set up so I can solve two different equations. If I know that 282 people attended overall, that means if I add X and Y together, I have 282 overall attendees. So this value in front of the X and in front of the Y is just a 1. So that's my first equation, just talking about total attendance. And then my next equation is going to talk about cost. So I know adult tickets cost $5, so I can say 5X. And then child tickets or children's tickets are $3, so I can say 3Y. And my revenue is $1,046, so I can set it up like this. So those are my two systems, or my two equations to construct the system. So next up, I need A, which is my matrix that involves my coefficients, or A, B, C, and D. In this case, those values are just 1, 1, 5, and 3. So when I set this up, I've got a 1, a 1, a 5, and a 3. So I want to find this determinant because I'll use that in Cramer's rule to then solve for X and Y. So here, A times D is 3 minus B and C together is 5. So this determinant is -2. So then I just have two more matrices to set up in order to solve for X and Y. For my X value, when I set up this determinant, remember that we're looking at this part of the formula over here on the right. So we want to set it up with E, B, F, and D. In this case, E is my constant of 282. That's going to go right here. B is going to be this value right here. So that's just 1. F is the big 1046 value. And D is the 3 term. So to find this determinant, I'm going to take 282 and multiply it by 3. That's my A times D. And I'm going to subtract off 1046 times 1. So I'm going to grab my calculator for this one. When I do 282 times 3, that gives me 846, and then I'm subtracting off 1046. So that answer is going to be -200. So in order to solve for X, all I have to do is take -200, divide by -2, and that's going to be 100 adult tickets because X is my adult ticket value. Now, one thing that we've talked about, you guys, is after you've solved for a value using one method, you can decide which method is the best to continue working through your operation. So we're going to solve for Y using Cramer's rule, but then we can talk about other possible methods that we could use to get that value as well. So for Y, we have one more matrix we need to set up, and that's the one with A, E, C, and F. So that matches to A is 1, E is 282, C is 5, and then F is still 1046. So to find this determinant of Y, we've got 1046, that's our A times D. and then minus 5 times 282. So if you just plug that whole expression into your calculator, 1046 minus 5 times 282, you end up with negative 364. Divide that number by our A determinant of negative 2. And when you do that, you get a Y value of 182 children tickets or child tickets. So when I'm working with matrices, I always have the option, once I've found one using Cramer's rule or any other technique with matrices, to decide whether I then want to use matrices again for the second variable or if I would want to plug in. So in this case, when I found the value of 100 here, I could have then decided to go ahead and take 100 and plug in for x here. So knowing if I had 100 of 1 to get to 282 overall, this would have to be 182. You can also just check your work that way, so you've got plenty of options. Now, one key point before we wrap up for the day is that when you decide that Cramer's rule seems like a good approach for solving a system of equations, you really need to pay attention to what this result is for the determinant of A. Because if the determinant of A is equal to 0, we can't use Cramer's rule. And the reason for that is if this determinant is equal to 0, that means you have either an infinitely many solution system or you have a no solution system. So you can make that determination using algebraic techniques, but not with Cramer's rule. So if you see this happen where your determinant is 0, go back and try solving it with substitution or elimination and see whether or not it's infinitely many, so any possible number of solutions, or no solution, that there's no value of x and y that makes it true. So that's all for now, you guys. You've got 6 practice problems to go try from the worksheet that's linked online, and then you can check your solutions by scrolling down on that worksheet below. Have a great weekend, you guys, and I will see you on Monday.